Hi, this is your Professor Sudha, section 3.2 Measures of Spread. In this section, you are going to compute the range of a data set, variance and standard deviation of a population and a sample, how to compute the coefficient of variation, and approximating the standard deviation with a group data, and empirical rule and Chebyshev's inequality. Objective 1, range of a data set. Range of a data set means that is the difference between the largest value and the smallest value. Here average monthly temperature in San Francisco is given. So we need to find the range. So look at the highest value or the largest value and the smallest value and take the difference between that, largest minus the smallest value. Here largest value is 63, smallest is 51. So 63 minus 51, that is 12, that is the range. Objective 2, compute the variance of a population and a sample. When the data set is small amount of spread like San Francisco temperature, most of the values will be close to mean. But when the data set has a larger amount of spread, more of the data values will be far from the mean. So variance is the measure of how far the values in a data set are from the mean on an average. Let x1, x2, x3 up to xn denote the value in a population of size n and mu denote the population mean and the population variance sigma square, that will be equal, that is sigma xi minus mu whole square divided by n. This is the summation notation. So if we expand this, this is basically x1 minus mu, mu is the population mean. So x1 minus mu square plus x2 minus mu whole square plus x3 minus mu whole square plus up to xn minus mu whole square. That means you are taking the difference between these values and mu and squaring, then you are adding all those together and dividing by the population size n. Why we are squaring here is, if we want square, this is the difference, right, x minus mu, that is the deviation. So this can be positive or negative. So when you add everything, the negative and positive values will cancel. That's why we are squaring that. The average of the squared deviation is the population variance. The population variance will never be negative. It will be equal to 0 if all the values in the population are the same. Otherwise, the population variance will be positive. Let's look at an example on population variance. First, we will find the population mean. That means add all these numbers and divide by 12. We are dividing by 12 because there are 12 months or 12 data or 12 numbers are there. So add all these and divide by 12, we will get mu equal 57.5. Then take the difference between each value and mu and square. So 51 minus 57.5 square plus 54 minus 57.5 square. So basically x minus mu square, x minus mu square. So all these are x values. So x minus mu square, like that. Continue that until 52 minus mu square. Then divide everything by 12, you will get the population mean. Next is sample variance S square. When the data values come from a sample rather than a population, the variance is called the sample variance. Population variance we use sigma square, but for sample variance we are using S square. And the formula are almost the same. Instead of mu, we will use the sample mean x bar. If the sample size is n, we will replace the n by n minus 1 instead of capital letter N. Then the formula will become x minus x bar. So we replace this mu by x bar and replace this n by n minus 1. Now you might be thinking, why do we have to divide by n minus 1 rather than just n? It turns out that the deviation using the sample mean tend to be a bit smaller than the deviation using the population mean if you divide by n rather than n minus 1. So, if you divide by n when computing the sample variance, the value would be a little bit smaller than the population variance. It can be shown mathematically that the appropriate correction is to divide the sum of the square deviation by n minus 1 rather than n. The quantity n minus 1 is sometimes called the degrees of freedom for the sample standard deviation. For a sample of size n, there will be n minus 1 degrees of freedom. Here lifetime of 6 batteries in hours are given. We need to find the sample variance. So, this is the formula for the sample variance. So, first we need to find the sample mean, and n is 1, 2, 3, 4, 5, 6, or here already says that 6 batteries. So, n will be 6, and x means these are the x values. So, first we will find the sample mean. So, add all these and divide by 6, we will get the sample mean as 6. Then take the difference between x and the sample mean, then square that and add. So, sigma, this is the sum. So, then we will take the difference, square and add, then divide that by n minus 1, that is 6 minus 1, that is 5. So, divide by 5. So, we can make a chart like that, or you can do everything in one step. So, this will be 3 minus 4, that is negative 1, and 4 minus 4, that is 0, like that. Then square everything. Now, add all these values, that is equal 10. So, the sample variance is 2. Objective 3, compute the standard deviation of a population and a sample. While calculating the variance, we use the squared deviation. In most of the situation, it will be better to use the measure of spread as the same unit as the data. In order to do this, simple way is take the square root of that. Since we squared, then take the square root again, we will get the value same unit as the data values. That quantity is called the standard deviation, and we denote that by, if it is a population standard deviation, we can denote by just sigma. If it is a sample standard deviation, it is just s, because this is the square root of the variance, this is the square root of the sample variance. In the first example, the population variance of temperatures in San Francisco is given. Find the population standard deviation. So, take the square root of that. And in the second example, the variance of lifetimes for a sample of 6 batteries given, that is equal to, find the sample standard deviation. So, take the square root of that. Objective 4, approximate the standard deviation using group data. So, first step is compute the midpoint of each class and approximate the mean of the frequency distribution. And for each class, subtract the mean from the class midpoint, then square that and multiply by the frequency, then add all those. For population variance, divide the sum by n. For sample variance, divide that sum by n minus 1. And if you take the square root of that variance, you will get the standard deviation. In this example, we need to find the sample standard deviation. So, first step is we need to find the mean. First, find the midpoint of each class. So, add these two divided by 2, add these two divided by 2, like that. So, for the last class, you need to add 250 and 300 and divided by 2, and these are the corresponding frequency. So, multiply each one and add, then divide by n, so that you will get the sample mean. Next step is find the difference between the midpoint and the sample mean. Then square each one and multiply by the corresponding frequency. Then add all these and divide by n minus 1. So, 50 minus 1. Then take the square root to get the standard deviation. If you take the square root of the variance, you will get the standard deviation. Objective 5. Use the empirical rule to summarize the data that are unimodal and approximately symmetric. Many histograms have a single mode near the center of the data and are approximately symmetric. Such histograms are often referred to as bell-shaped. So, this is a bell-shaped histogram. When a data set has a bell-shaped histogram, it is often possible to use the standard deviation to provide an approximate description of the data using a rule known as the empirical rule. Empirical rules state that approximately 68% of the data will be within one standard deviation of the mean, and about 95% of the data will be within two standard deviation of the mean, and almost all of the data will be within the 3 standard deviation of the mean. Let us look at an example on how to use empirical rule to describe the data. This data represent the percentage of the population age 65 and over in each state and the District of Columbia. Find the mean and standard deviation using a calculator. Then find mu plus or minus sigma. So, use these values for mu and sigma. Then round your answer to 2 decimal places. Then find mu plus or minus 2 times sigma and round the answer to 2 decimal places. Then find mu plus or minus 3 times sigma and round the answer to 2 decimal places. We can interpret these values and conclude that the percentage of the population age 65 and over is between 11.57 and 14.93 in approximately 68% of the states, and between these two values approximately 95% of the states, and between these two values in almost all the states. Objective 6. Use Chebyshev's inequality to describe a data set. When the distribution is bell-shaped, we use empirical rule to approximate the proportion of the data within 1 or 2 standard deviation of the mean. We can use Chebyshev's inequality for any data set, whether it is bell-shaped or not bell-shaped. That means we can use for any data set, and this is the formula we will be using, and we will substitute 2 first. So, if you substitute 2 first, 1 minus 1 over 2 square, that means 1 minus 1 over 4, that is 3/4. 3/4 in percentage is 75%. So, we can say at least 75% of the data are within 2 standard deviation of the mean. Then substitute 3 here, 1 minus 1 over 3 square, and if you simplify that, you will get 8/9. 8 over 9 in decimal is 88.9%. So, we can say that at least 88.9 of the data are within 3 standard deviation of the mean. Let us look at an example. As part of a public health study, systolic blood pressure was measured for a large group of people. The mean was 120 and the standard deviation was 10. What information does Chebyshev's inequality provide about this data? Mean is 120 and standard deviation is 10. So, to standard deviation from the mean means you need to add or subtract 2s or 2 times of the standard deviation from the mean. Then 3 standard deviation from the mean means you need to add or subtract 3 standard deviation from the mean. So, I replace this mean and the standard deviation with these values and I calculated. And we can conclude that at least 75% of the people had systolic blood pressure between 100 and 140. And at least 88.9% of the people had systolic blood pressure between 90 and 150. Objective 7, coefficient of variation. Coefficient of variation tells us how large the standard deviation is relative to the mean. It can be used to compare the spreads of data set whose values have different units. Coefficient of variation we can find by dividing the standard deviation by the mean. Let's look at an example. National Weather Service record shows that over 30-year period, the annual precipitation in Atlanta had a mean of 49.8 inches with standard deviation 7.6 inches. And annual temperature had a mean of 62.2 degrees Fahrenheit and standard deviation 1.3 degrees. We need to find the coefficient of variation for precipitation as well as for temperature. Then we need to conclude which has the greater spread relative to its mean. Find the coefficient of variation for precipitation. Formula is sigma divided by mu. So, sigma is 7.6 divided by the mean. Also find the coefficient of variation for the temperature. So, standard deviation divided by the mean. Then compare these two values and we can see that coefficient of variation for precipitation is larger. Therefore, we can conclude that the precipitation has a greater spread relative to its mean. In this section, you learn how to compute the range of a data set and the notations for the population variance, population standard deviation, sample variance and sample standard deviation. Also how to compute the variance and standard deviation for population and samples. Also how to approximate the standard deviation for group data, and you learn how to use the empirical rule to describe a bell-shaped data set. Also how to use Chebyshev's inequality to describe any data set, and how to compute and interpret the coefficient of variation.